Hello and good morning, everyone. So today we are going to discuss our last mock test. And in today's discussion, which topic I've largely excluded is the one that we have heavily discussed before, right? In the previous test discussion, I discussed a lots of questions from mechanics. Basically, from rotation, I discussed a lot of questions. So in this section, I have removed that angular momentum calculation part of thing and all. There was a question match and column. So I've removed that because we have done it quite much. Done. So in this section, again, we will be focusing only on the easy and average questions. Done. And there were many actually. So let's go through the question. Let's discuss some. So first, I have picked up paper one. So in paper one, the very first question that I picked up is the very first question. And this question was quite easy, isn't it? Like we just needed to look at the question carefully and apply the basic formula. Then what the question was, there is a stone projected at an angle 60 degree from the ground level, strikes at an angle 30 degree on the roof of a building of height h. Find the speed of projection of a stone in meter per second. We have to calculate its initial velocity of projection, right? Here, angle of projection is given, and the angle at which it is striking the roof is given. Also, the height of this roof is given, that is 30 meter. We have to calculate u, right? How we can do that? Then, so what the information we are having, just this is a projectile motion. So what happens in projectile motion? Its horizontal component of velocity will remain same throughout, because if we neglect air friction, that we do most of it. If nothing is given, then horizontal velocity component will remain constant. Initial horizontal velocity is how much? U cos 60, right? And if at this point its velocity is v, then this must be equal to what? V cos 30 q. You can see here what's happening at this point. Velocity direction is making an angle of 30 degree with the horizontal. So horizontal component is this. Now, if you're going to write this, u by 2 will be equal to v into root 3 by 2. So there is a relation between u and v, u equal to v root 3. So v equal to u by root 3. Done. So that we have got. Now let's deal with writing equation of motion in the y direction. So in y direction, what information we are having? It started from point O and it is landing at point A. So in y direction, how much distance it has covered? Here y component is 0, y value is 0, and here how much y coordinate is there? That is h, 30 meter. If we are taking upward direction as positive, then it will be treated as plus 30 meter, right? So we can write second equation of motion, that is equal to how much? S equal to ut plus half AT square, and in the y direction, initial displacement was 0, final displacement is 30 meter. So S used to be generally what? Displacement. Done. So 30 minus 0 equal to what you will be writing? What is the initial velocity in the y direction? Sorry, not second equation of motion will serve our purpose, क्योंकि यहाँ तो time आ रहा है. Sorry, we don't need to calculate time now. We need to calculate, u. So let's go with the third equation of motion. Okay. So v square will be equal to u square plus 2as. Again, s is what? Displacement. V square. So vy ka square equal to uy ka square plus 2ay sy. So let's put the values now. So vy will be equal to how much? That will be equal to v sine 30. Done. Equal to uy ka square is how much? U sine 60. So here you write u sine 60 plus what you are going to write? 2 into acceleration due to gravity is in downward direction. Done. And if you are treating downward direction as negative, upward direction as positive, then s will become positive, ay will become negative. So 2 into minus g into 30. Done. Now we have two equations and we have two variables. Just here you can put the value of u. We need to calculate u, right? So just put the value of v equal to v यहाँ पे मैंने लिखा है. So just write v equal to u by root 3 and you will be getting the answer, right? So this was this much easy. This was the easiest question, I must say. So this was very much easier. And please, in the exam, don't escape such kind of question. Have everything in your head, take patience, don't panic, just look at the question carefully with love, with attention, and solve it. Okay? So easy question, you should not leave in your exam. Now again, this question was also very much easy. Under easy category only, this will fall. Now what the question was, a particle is projected from point A. So point A is here. And from point A, what you are doing, we are projecting it. And this point A is at a distance 4r from the origin at the center of Earth with a speed v1 we are projecting. v1 is making an angle 30 degree with the vertical direction. Done. So this is 30 degree. And like if you get to see Earth now, what will be the vertical direction? Vertical direction is direction directed away or towards the center of Earth. And what is the direction here? Horizontal direction. That is along the surface of Earth. Just for your information, I've given. In this question, you won't get this application, just for the information. Okay. So making that 30 degree with the line joining center of Earth and point A as shown, the particle passes grazing the surface of Earth. So it is grazing the surface of Earth. Again, if diagram were not given in the question, how you would have drawn it? Like it said that it is grazing the surface. Grazing the surface means it is passing tangentially through the surface. Done. So that's given. Consider gravitational interaction only between these two. Only force acting is gravitational interaction. V1 value is given as root under 400 n. Actually, this n is also under root. Done. But in the question, it was not quite clear. It seemed like n is outside, but it's inside. Then find the value of n. Then we needed to calculate what? We needed to calculate value of n. How we will do that? You just see here, only force acting is gravitational force. Gravitational force is a conservative force. First thing that should come in our head, energy conservation will get used, right? So apply the energy conservation. What will be the energy at point A? So energy at point A will be sum of kinetic plus potential. What's the kinetic energy? That is half m v1 ka square. What will be the potential energy here? Potential energy will be negative. Because gravitational force means attractive force, so minus gm mass of Earth into mass of that object divided by 4r. So this is the initial energy. Now, what's the final energy? Final point is this. So final energy is half mv2 square. And what's the final potential energy? If you look at carefully, that will be minus gmm by r. So this is our final energy. Now, if energy conservation is true, that will be true actually. Because force acting is conservative, you need to equate these two. Now we have to calculate V2. We have to calculate what? If V1 equal to itna, then find the value of n. V1 we have to calculate. So we have one, like if you're going to compare this EA equal to E initial equal to E final, then we are going to get one equation, and in that one equation there will be two variables V1 and V2. Done. So we need to have one more equation. Now one more equation we can write from where? One came from the energy conservation again. Now look at carefully, wherever I have told you before as well, wherever you have to find out two relations in such kind of questions in mechanics. If you're doing conservation things, second kind of conservation that can be done is momentum conservation or angular momentum conservation. Now, here individually we can't conserve the momentum of this body. Because if we are taking this body as a system, Earth will become external to it and it is applying a force on this object. So its momentum will not remain constant over time. But what can remain constant? That's the question now. So if we consider, if we calculate angular momentum around the center of Earth, then what will happen? Will angular momentum be conserved or not? You just see here, whatever force is acting on this object is always acting towards the center of Earth. So if force is passing through this center, and if we are calculating angular momentum around this center, always it will remain conserved, because torque of this force torque of this force around center is going to be what? 0. So if tau external, there is external force acting, but tau external around center of mass, around center of earth is what? 0. Around C, it is 0. So if we calculate angular momentum around point C, it will remain same throughout. Done. So initially, what will be the angular momentum around point C? Angular momentum initial, let's write. So that used to be equal to R cross MV. Done. So initial MV is in which direction? You just see carefully. Initial MV is in which direction? So initial MV is in this direction. R cross MV we have to do. So R around this point we are calculating. So R cross MV. Then how much angle is there between R and MV? It is 30 degrees. So initial momentum will be how much? R value is how much? 4R into mass into velocity, that is V1. Angle is how much? Sine 30. Now let's calculate the final momentum. So if you're going to calculate the final momentum, finally it is here. So R cross MV. Again, this angle is 90 degrees because it's scratching the surface, right? So this angle is 90 degrees. Now what you will be writing here? Here angular momentum value will be M into R into V2. And these two values of angular momentum must be equal because tau external torque around point C is 0. Now conserve these two angular momentum, you will be getting second equation of motion. So 4R into M into V1 into sine 30. Sine 30 is half. So this will come as 2R into MV1 and this will come as MRV2. Done. So MR will get cancelled. And what is the relation between V1 and V2? V1 is equal to V2 by 2. Now, if we have to calculate V1 in first equation what we got? First equation we will get like half M V1 square minus G mm by 4R was equal to how much? Half M V2 square minus G mm by R. So if we are going to calculate it, what value we are going to get? G mm by R 1 minus 1 by 4 will be equal to how much? Half M V2 square minus V1 ka square. Done. Put the value of V2 here. You will be getting the value for V1, right? So that was the way we needed to calculate. Done. So here basic thing was key from where we are going to get the two equations. We needed to calculate V1. 2 points were given. Energy conservation and angular momentum conservation. Just remember that the linear momentum conservation we can't do always if external force is acting. We can never do that. But even if external force is acting, we can do angular momentum conservation by selecting the point very wisely. Just select the point around which torque of that external force is becoming 0. Then you will be able to conserve angular momentum around that point. So that should be a point in your head. Okay? Chalo. Now this was the question. Again, in this question, what you can see, there is a potential energy curve and that is shown graphically for a particle. Then potential energy does not depend on y and z coordinate. It is only dependent on the x coordinate. Then the maximum value of corresponding conservative force for range 0 less than x less than 2. In this range, we have to calculate value of maximum conservative force. Okay, value of maximum conservative force is given as n, then find the value of n. Okay, n का value हमें निकालना है. How we will calculate the value of conservative force from potential energy? Here potential energy curve is given. U versus x curve is given, right? And we have to calculate the maximum value of what? Conservative force. If you remember how we calculate conservative force from potential energy, very easy. Conservative force is equal to minus du by dx. You already know this, right? Now, if you know the equation of u, you can very easily calculate this. And here the graph of u is given, and that graph is very much simple. This is a sine curve. And here angle is varying with what? X. So, yahan pe, what we can write about how we can write the sine curve, that's only the thing here. Okay? If you are able to do that, you are done. So यहाँ पे आप देखो, if this equation is something like this, if this is x and this is y, so how you will write this equation of this sine curve? So y will be written as amplitude a sine kx. Simply this, क्योंकि here this curve is not changing with time, it is changing with x. So I have simply taken a sin kx. Okay. Now amplitude must be given in the question. Now what is happening here? Origin is this, right? Origin is this. From here, our curve is not starting. Our curve is starting from where? यहाँ पे. From 0, 3. Okay. So initial value of y is how much? Initial value of y is not 0, it is 3. But here, if we put x equal to 0, here if we put x equal to 0, y will become what? 0. But we have to make y equal to 3 at x equal to 0. So what we can do here, तुम लोग maths के student हो, you must be knowing it. So we can write like y minus 3, क्योंकि initial position of y is what? 3. So y minus 3 equal to a sin k x minus 0, because initial position of x is what? 0. So like this we can write, right? In pure mathematics term. Now this will become y equal to 3 plus a sin kx. This is our required equation, right? Along the y-axis, what is there? Potential energy. So y को replace कर दो आप किससे? This is equation of u. Now we need to calculate what? Minus du by dx. So now differentiate it, simple. Now you will be getting the answer. So if you're going to differentiate it, a differentiation of 3 will become 0. Differentiation of a का value यहाँ पे कितना है? If you see carefully, a का value is 6 minus 3. That is 3 here. ठीक है? So that I'm going to write now. So 3k cos kx. That will come that will be the differentiation value here. है ना? That is your how much? 3k cos kx. Now we have to calculate maximum value of potential energy. This value will be negative, right? Because minus du by dx is conservative force. So force will come as minus of 3k cos kx. Now its maximum value will be how much? Sorry, 3k hai na? Done. 3k cos kx. Now maximum value of this will be how much? Its maximum value will be 3k. Because here is a minus sign. Maximum value of cos kx can be how much? 1. Done. In that case, force will remain negative. We have to maximize it. Let's make it positive. So kx ka value we can take as what? Pi. So cos pi will become minus 1 and its maximum value of force will become 3k. Now we need to calculate the value of k, right? K is what? K is wave number and that is equal to 2 pi by lambda. Now what is the lambda from the equation? You can see here clearly. यहाँ से यहाँ का distance. This will be lambda, no? And this lambda value is how much? 2. So यहाँ पे lambda का value of 2 रख लो. So answer will be 3 pi. 3 pi. Pi का value 3.14. So 3 into 3.14. Something 9 point something you will get, right? So the correct answer was 9.4. So you simply needed to write the equation, nothing else. Over. Now again, this question was damn easy. We just needed to remember the formula and I have discussed it. How we calculate I maximum. How we calculate I minimum. If you remember the formula, I have given I max equal to root I1 plus root I2 ka square. And what's the value for I minimum? Root I1 minus root I2 ka whole square. This one, right? So we were given two waves. Y1 was this, its amplitude is 0.3. Forget about its argument, forget about its phase. Its amplitude is how much? 0.3. Y2, its amplitude is how much? 0.5. The ratio of maximum and minimum intensity of peak. What will be the ratio of maximum and minimum intensity? And you further know that the intensity जो हमारा होता है, that is directly proportional to A का square. Okay, so if I am here writing root I1, so root I1 will be directly proportional to what? Amplitude. I is directly proportional to what? A ka square. So root I1 will be directly proportional to what? A. Done. And here A value is how much? 0.3. And here, yes, A1 value is how much? It is equal to 0.3 and A2 value is how much? It is equal to 0.5. Okay, so root I1 will be directly proportional to A, so that will be proportional to A1 0.3 and this will be proportional to how much? 0.5. 0.3 plus 0.5 कितना होगा? 0.8 का square you will be writing here, right? And here what you will be writing, it will be written as some constant होगा यहाँ पे, कुछ भी आप ले लो, क्योंकि ultimately you have to calculate the ratio ना, so constant will not matter. अब यहाँ पे रूट I1 के लिए आप अगेन यहाँ पे क्या लिखोगे? रूट I1 माइनस रूट I2, so I1 is less, so रूट I2 माइनस रूट I1 करेंगे हम लोग, so what we are going to get? 0.2 का square. If you are going to take the ratio, what value we are going to get? 4 का square, that is 16. So answer was this much easy. Done. And question was so easy. You only needed to remember the formula, and this was your formula, right? Now let's come back to this question. Again, this question was very much easy. You know, if such kind of questions are coming now, you should not miss it. So read the question carefully. What the question was given: a small ball is projected from point P on floor, done, towards the wall as shown. It hits the wall when its velocity is horizontal. Yani ki, you have thrown this from here, and when it is hitting the wall, it is hitting it horizontally. यहाँ पे हमें दिख नहीं रहा ये horizontally, मुझे नहीं दिख रहा. But in the question, it is given that it hits the wall when its velocity is horizontal. Now, here the velocity is horizontal. See carefully. At point P, it is getting thrown at some angle. Suppose it is getting thrown at some angle theta. So initial velocity in the x direction is how much? U cos theta. In the y direction is how much? U sin theta. Then what will happen? If it is hitting it horizontally, it means what? The projectile becomes horizontal during projectile motion. Velocity become horizontal where? At its maximum height. And at that point, Vy used to be what? 0. Done. So what is happening here? The moment it is striking, it has only velocity in the horizontal direction, and its velocity must be equal to U cos theta. Done. Kyunki velocity in the x direction doesn't change. We already know. Now what is happening? Here it is colliding, and this collision is not completely elastic. Here the coefficient of restitution is suppose E, and this is same for all the surfaces. It's given in the question. So यहाँ पे velocity with which just before the collision, velocity of the ball was how much? U cos theta. What will be the velocity after collision? After collision, what will happen? It will return. Done. So if ball is hitting horizontally like this, it will also come back horizontally like this with certain velocity. What will be that velocity here? So coefficient of restitution is given, not in digit, but we have to assume it. Suppose it is E. So in terms of coefficient of restitution, what will be the value of velocity of coming back? What will be that? So we know that E equal to what? Velocity of separation by velocity of approach. So velocity of separation will be what? With whatever velocity it is coming back, so let it be V. Velocity of approach is how much? With what velocity it approached the wall? With velocity U cos theta. So what will be the velocity after collision? It will be E U cos theta. Now with that horizontal velocity, it is falling down here. And what else is said? Ball reaches P after one bounce on the floor. If the coefficient of restitution is same for the two collision, find its value. Now you look at the thing very carefully again. What is happening here? It is coming with some horizontal velocity, and when it is hitting the ground at this point, look at carefully at point P. Sorry, P dash suppose. So at this point, it is hitting the ball, hitting the ground vertically. So if it is hitting the ground vertically, means at this point, it has. It seems like vertically. Let's see me carefully here. Okay. So that's given in the question or not? Rishabh, V will be negative. Yes, definitely that will be negative. मैंने direction ये दिया ना. So actually velocity of separation will be V minus 0. So actually in direction term it is negative, but मैंने सिर्फ modulus लिखा है यहाँ पे. So velocity is E U cos theta. So it's coming something like that. ठीक है? Done? Clear है? Okay. So what's happening here now? As it is coming down, what will happen? It has horizontal velocity of how much? EU cos theta. This is the horizontal velocity of this ball. And as it will come down, it is coming down from the maximum height. So it will gain that vertical valley velocity. It will gain that vertical valley velocity. Done. So what was the vertical velocity? Initially, it was u sine theta. And because of that vertical velocity, it reached the maximum height. And from that same maximum height, now it is coming back to the ground. So just before it will reach the ground, its velocity in the y direction will become how much? U sine theta. So here velocity in the y direction will become how much? U sine theta. Done. Now just see the thing carefully here. If ball is falling like this, it has some horizontal velocity in this direction. It has some vertical velocity in this direction. How much vertical velocity it has? U sine theta. Okay. That is clear. यहाँ पे vertical velocity क्या होगा? U sine theta. Horizontal velocity will be U cos theta. Now during collision, which direction you will consider? That's the important here. If ball is falling down, you just remember, you just visualize कि अगर ball किसी भी surface पे ऐसे गिरता है, ground will apply on it force in which direction? In the vertical direction. So if mutual force is acting in the vertical direction, it means collision is acting in the vertical direction, right? So in vertical direction, we need to consider for collision. So what will be the velocity of ball after collision? After collision, its horizontal velocity will remain as EU cos theta. क्यों? क्योंकि in horizontal direction, no force is acting during collision. During collision, only force is acting in the vertical direction. Done. So we in the horizontal direction, its velocity will remain EU cos theta. And what will become its velocity in the y direction after collision? So just before collision, velocity in y direction is u sine theta. Just after collision, its velocity will become upward. Initially, it was downward. It will become upward, but how much? So again, we will use this coefficient of restitution E equal to velocity of separation. So V लिख लो, velocity of approach, magnitude मैं बस लिख रही हूँ, U sin theta. So V again will become how much? EU sin theta. Now my question is done and dusted. How? क्योंकि अब मुझे पता चल गया कि with what velocity it is going in this trajectory. With what velocity? At this point, it will have horizontal velocity equal to EU cos theta. EU cos theta. And what will be the vertical velocity? Vertical velocity will be EU sin theta. So angle of projection here is same. Angle of projection is what? Theta only. If you are going to calculate value of what? Tan theta, again you will be getting what? Ux by uy. जैसे यहाँ पे देख लो, जैसे EU cos theta is ux, EU sin theta is uy. Angle of projection is what? Theta only, na? It's visible from the equation. Now what we need to calculate here, if the coefficient of restitution for the two collision is same, find its value. E का value हमें निकालना है. How we will do that? Now the question is very easy. अब आप यहाँ से देख लो. Initially, let me go on to the second page. So initially, when you threw it, what was the case? At some angle you threw it, then it hit it vertically. So this distance was equal to how much? This distance was equal to r by 2. This is equal to how much? If you consider this distance, this is equal to how much? R by 2. For initial values, angle of projection, यहाँ पे theta ले लो. Initial velocity of projection is u. So for this value, if you are putting these values and you are calculating this distance, it will be equal to r by 2. So this distance is r by 2 and its value will be equal to how much? Ux uy by g, 2ux uy by g, 2u cos theta into u sin theta. And if you're going to solve it, it will come as u square cos 2 theta. Yeah, sin 2 theta. What is the formula? Sin 2 theta, no? Yes, what's the formula? Rishabh.
Sin 2 theta.
Sin होगा ना? हाँ, done. बोलते बोलते भूल जाती हूँ. So this will become what? U square sine 2 theta by g. So in term of this, we know the value. अब देखो ये वैल्यू निकालने का एक और तरीका है. What the तरीका is that कि इस क्वेश्चन को दूसरी तरह से हम देख सकते हैं कि what is happening after collision from this surface. From here it is getting, we can say that a projectile is getting projected with horizontal velocity, and it has landed here like this, and again it is going like this. So this is the range for this projectile. Done. And here the angle of projection we know, EU cos theta. Sorry, initial velocities we know, EU cos theta is the ux, EU sin theta is what? Uy. So in this term we can calculate this distance r dash, and this distance also we can calculate. How? This is h. Done. This is what? H. And h we can calculate from the first values. How? Because this h is nothing but the maximum height by the first case of projectile. Done. So that will be equal to how much? U square sine square theta by 2z. Done. So this distance we already know. Done. If we know this distance, we can calculate time of flight for this one. Done. So we can calculate t, and if we know t, we can calculate this distance. This distance will become equal to t into EU cos theta. So this distance is equal to how much? This distance again we can write as how much? वो मैं लिख देती हूँ यहाँ पे. How we can write that? Range. So range is EU cos theta into EU sin theta. 2 लिखोगे, 2 ux uy, that is the range formula, divided by g plus, so this distance I have written, this distance will be equal to how much? Because this distance is covered in horizontal velocity, so horizontal velocity, that is EU cos theta into time taken to fall from here to here, and that will become equal to how much? From here to here. Here its velocity is only horizontal. Done. So initial vertical velocity is how much? 0 for this projectile, for second case of projectile, right? So if we are going to calculate in how much time it is coming down by h height, we can write here h equal to uy t. uy क्या हो जाएगा हमारा? 0. वॉइस तो जा रही है ना? You are not connected, Nihal. Nihal, your audio is not connected. That is why I am not audible to you. So यहाँ पे h equal to what you are going to write? Half a y t square. ठीक है? So h value we know, u square sin square theta by 2g. तो यहाँ पे t का वैल्यू मैं लिखने वाली हूँ. t स्क्वायर कितना होगा? 2h by g. So root under 2h. h का वैल्यू कितना है? u square sin square theta by 2g. So this is what? This is 2h by g. Again g. So this is the value, and this must be equal to this much. Done. So equate it. I explained, that is why it took lots of time, but if you know the things, you will simply keep on writing, and finally you will be writing the answer. Okay, it won't take this much of time. To the extent I took, you won't be taking. है ना? Chalo. Any doubt in this? Any doubt in this? चलो, डाउट नहीं है. Okay, done. Let's move on to the next question then. So yes, this is the question. One question I've included. I've largely avoided to include question from rotation. क्यों? क्योंकि in previous stage मैंने बहुत सारे question discuss. एक second, Nihal, you okay, you did. Okay, done. I am muted also. Anyway, range की. अच्छा, हाँ, done. ऋषभ, you are correct. ये वाला वैल्यू बाई 2 होगा. डन. क्योंकि दिस इज नॉट होल रेंज फॉर द फर्स्ट वाला प्रोजेक्टाइल ना, दिस इज जस्ट हाफ, सो बाई 2. थैंक यू. सो दैट विल बी डिवाइडेड बाई 2. कैलकुलेशन. थैंक यू. नाउ दिस क्वेश्चन रोटेशन से मैंने पहले भी स्टार्टिंग में ही बताया, आई हैव नॉट इंक्लूडेड मच क्वेश्चन क्योंकि इन द प्रीवियस टेस्ट डिस्कशन आई हैव डिस्कस्ड अ लॉट फ्रॉम देयर, बट स्टिल I included this one because this one was very much easy. Again, there is a rod CD here, you can see, of length L and mass M is placed horizontally. ठीक है, इसका length L है, mass M है, this is placed horizontally, surface is frictionless. Again, if surface is frictionless, question is going to be very easy. A second identical rod, you can see here AB, and that is moving with certain velocity V, you know. And this is also placed on the same horizontal surface. And this is moving in direction perpendicular to rod CD. And its end B strikes the rod CD. इसका जो end B है ना, वो rod CD को strike कर रहा है at end C. Done. And it sticks to it rigidly. After that, after collision, it is sticking to it. Again, more easier. Then we have to see all these things. So सबसे पहले एक काम करो, just draw the diagram carefully. So this is the rod AB. At the time of collision, I'm going to draw it. So at the time of collision, it will look something like this. This is C, this is D. Done. Now, the speed of center of mass of system just after impact is system. Here system is what? Speed of center of mass of the system. So in the system, we have two rods, right? AB and CD. Done. So my system is AB plus CD. Always I have focused on this part. Identify system. Done. Your question is over. So here system is AB plus CD. Now during collision, which two is colliding? Inside system, if you go, AB and CD are colliding. So during collision, force will act, but this force is in between the system. No force is acting out of the system. So here what will happen? Momentum will remain conserved. यहाँ पे मोमेंटम भी कंजर्व होगा, राइट? क्योंकि वो जो भी फोर्स लग रहा है, दैट फोर्स इज एक्टिंग इन बिटवीन सिस्टम, राइट? नथिंग एक्टिंग फ्रॉम आउटसाइड, सो मोमेंटम विल रिमेन कंजर्व्ड. So just before collision, just see what is the value of momentum of system. So in system, only this AB is moving, CD is not moving. So initial momentum of the system, if I am going to write, I will write M into V. And what will be the final momentum of system? Finally, these two bodies are acting as one because they are getting stuck together. So its mass will become 2m. Its mass will become how much? It will become 2m. And let's its velocity be v dash. So final momentum of system will be 2m v dash. And this velocity must be in the forward direction. Because initial momentum of system is in forward direction. So this must be equal, right? M, if you cancel, B dash will be equal to V by 2. So speed of center of mass of system just after impact is V by 4. No. Where else is given? Yeah. Speed of center of mass of system just after impact is V by 2. Yes. So this is this. Now angular velocity it is asking. What will be the angular velocity? How we will calculate that? So again here, what will happen? Around center of mass of the system, its angular momentum will also remain conserved, right? So first try to locate the center of mass of this system. तो चलो ये काम कर लेते हैं. Where will be the center of mass of this system? So this body center of mass will be here. This body center of mass will be here. Where will be the center of mass of system? For that, let's choose any origin वाला point. तो चलो मैंने origin यहाँ मान लिया suppose. So where will be the center of mass? सबसे पहले x cm निकाल लो. So what will be the value of x cm? So if this is origin, I am considering this as the x axis, this as the y axis. Done. So center of mass of AB rod coordinate is where? 0, 0. Done. And center of mass of CD rod coordinate is where? It is here now. So iska coordinate with respect to this origin will become how much? X will become L by 2 and y, because this distance is L by 2, and y will also become how much? L by 2. Now let's calculate XCM. So m into 0 plus m into L by 2 divided by 2m. So this will come as how much? You will get L by 4 as the answer. Okay, XCM. Now YCM similarly will come as L by 4. It's very much visible. So L by 4 is the center of mass with respect to this origin. So let's denote that point. So that point is where, suppose it is, sorry, it will be somewhere down now from this point. That is L by 4. ठीक है? So let's indicate that first. तो यहाँ पे मान लेते हैं. Its coordinate is how much? L by 4. L by 4. Now, finally, what is happening? Finally, they are sticking together and they will move. Okay? So, initial angular momentum of the system will be how much? You just calculate now. Let me know. I want you all to do it. Calculate initial angular momentum. ठीक है? वो मुझे निकाल कर बताओ और फाइनल एंगुलर मोमेंटम निकाल कर बताओ what you are getting. I want you to do it now. If you have already done it, let me know. Otherwise, you do it. I'm giving you 1.5 minutes. ठीक है? चलो करके बताओ क्या आएगा. It's very important to learn ना, क्योंकि देखने के बाद तो चीजें लगती हैं हाँ ऐसे ऐसे हो जाएगा. But when you actually go on to do it ना, you actually get what the doubt may be. ठीक है? So करके बताओ जल्दी से. Yes, I'm here only. If you need anything to know, let me know. Otherwise, do it. Yes. Getting it, or you want me to do? Okay, let me tell you. Initial angular momentum we have to calculate, right? So यहाँ पे आप एक काम करो. Initial angular momentum just before the collision we will calculate now, or whenever you calculate doesn't matter. अब यहाँ पे around which point we have to calculate, that we should select very much wisely. तो यहाँ पे I have already told you कि always calculate torque or angular momentum around either center of mass or around the point it is fixed. So there is no point around which these two rods are hinged, fixed. But we have another option around center of mass. So let's do it. So center of mass of these two bodies just before the time of collision is where it is somewhere here, right? And this distance is how much? Its y coordinate is how much? L by 4. And its x coordinate from here is how much? That was also something L by 4, right? Here it is L by 4, L by 4. Done. So just before collision, center of mass location is this. Now, let's calculate the initial angular momentum. तो चलो मैं इस rod को ऐसे draw कर लेती हूँ क्योंकि उस time पे rod कुछ ऐसा होगा. Done. Initially, only this rod is moving. This is not at all moving. This is at rest. Its velocity is 0. Its omega is 0, right? So it will have no angular momentum around this point. What about this? This has linear momentum. How much? mv. And if we have to calculate angular momentum around any point, how we do it? R cross mv. Around which point we have to calculate? Around this point O. So R cross mv. And that is in this direction, right? Anti-clockwise direction. How much? R into mv. This much we are getting, right? Initial angular momentum. And what is the value of R here, R is L by 4. So this is mvl by 4, initial angular moment. Now, how we will calculate the final angular momentum? Finally, what is happening? Finally, these two bodies are becoming one, and their center of mass, these two bodies are becoming one, and their center of mass is moving with velocity v dash. Okay? So this center of mass is moving forward with how much velocity? V dash. We are calculating angular momentum around this point only. So around the point which is traveling, which is going forward with velocity v, around this point we are calculating the angular momentum. So angular momentum of these two rods, because of its linear velocity v dash after collision, will be 0. That translation component wala 0 hoga na. Let me show you here. What was the case? यहाँ पे ये ऐसा था, यहाँ पे ये ऐसा था, ठीक है? After collision, they are sticking together. We are calculating angular momentum around this point. So around this point we are calculating. Done. Now these two are acting as one, and these two acting as one will have center of mass here, and this is moving forward with velocity v dash. Done. So if you are going to calculate r cross m to m v dash, that will become 0, क्योंकि m v dash line is this, and its perpendicular distance from this point is 0, है ना? जैसे किसी भी point के around अगर suppose कर लो, this is the linear momentum p, and if we have to calculate angular momentum of this body around this point, we check कि we draw a line passing through this point, and then we see the line of momentum of particle, and we see ki how much perpendicular distance is between these two. If this perpendicular distance is 0, that is, if this body is passing through this point, it will have angular momentum 0. So because of translation, these two body acting as one will have no angular momentum, but it can also rotate. It can also rotate, you know, around this point like this. How? Because here what happened? During collision, what happened? Some force acted, done, and this force can have torque around certain points, so this can also rotate, done. तो suppose कर लो कि this whole body acting as one, क्योंकि दोनों एक साथ है, its angular momentum को आप ओमेगा ले लो, ठीक, sorry, angular velocity को ओमेगा ले लो. So because of this angular velocity, how much angular momentum it has? It will have. So just check around which point we have to calculate the angular momentum, around this point. So we will calculate moment of inertia of these two systems around this point. Let it call I, and if this is omega, so we will write I omega, है ना? क्योंकि क्वेश्चन में हमें निकालना क्या है? ओमेगा का वैल्यू भी चेक करना है ना. Done. So we have assumed कि both bodies are rotating with angular velocity omega. Now its angular momentum because of rotation around center of mass will be how much? I omega. I is what? Moment of inertia of these two system around this point. What will be that value? अब आप वो carefully निकाल लो. I का value carefully निकाल लो. तो this was the center of mass of first. This was the center of mass of second. है ना? डायग्राम गलत दिख रहा है. ये L/2 होगा और ये भी क्या होगा? L/2. And this distance was how much? L/4. Now moment of inertia of this rod around this point is how much? mL²/12. So we can use parallel axis theorem. We will see around this point and around this point how much distance is there. So this distance is how much? L/4. Done. And this distance is how much? L/4. So how much will be this distance? That will be L²/16 plus L²/16 root over, and that will become 2L²/16. So that will become L/2√2. So this distance is how much? L/2√2. Now what will be the I1 value? First body ka? That will be mL²/12 plus m r ka square, parallel axis theorem we are using, L/2√2 ka square. Now what will be a linear moment, sorry, what will be the moment of inertia for the second rod? So इसके लिए भी around center of mass mL²/12. Around this point, just calculate this distance. Again, that will come same now. You just see here diagram. How much is this distance? This will become, let's see from here now. सही से दिख नहीं रहा. So its center of mass is here now. this distance we have to calculate. How much will be this distance? This is, its x coordinate is how much? L by 2. L by y coordinate is L by 2. Its x coordinate is how much? L by 4, and its x coordinate is how much? L by 4. So what will be the delta x value for this distance? Delta x value will be L by 4. Delta y value will be L by 4 again. Done. So same value we will be getting here also. L by 2 root 2 will be the distance. So I2 will be equal to I1. How much value? This much only. Now you calculate I omega. So what will be the value of I omega here? That will be equal to 2 into ml square by 12 plus ml square by 8 into omega. And this will be equal to initial angular momentum. And how is that value? How much is that value? MVL by 4. So इसको equate कर देते हैं किस चीज से? This one, इसका value चलो निकाल लेते हैं. So how much will be the value? यहाँ पे 2 लिख रही हूँ मैं. 3. So this will become 5 ml square by 24 into 2. So that is equal to how much? 5 ml square by 12. तो आप यहाँ पे लिख दो 5 ml square by 12. ठीक है. How much value we are going to get? M will get cancelled. 1L will get cancelled. And this was omega, no? So 3V by 5L is going to be the answer. Where is that? B. ठीक है. So why I discuss this question? क्योंकि एक और क्वेश्चन था आपका match the column. I didn't include both question. क्योंकि if you are able to understand the concept behind this question, match the column था ना, जहाँ पे different points के around you needed to calculate the angular momentum. Please, after class, you try attempting that question. ठीक है? Then you will get clear idea of how to calculate angular momentum thing. Then you won't get stuck in any kind of such questions. ठीक है? One concept I have already explained before, also I have done, but today also I have done. तो आप उस क्वेश्चन को जरूर सॉल्व करना. पेपर 1 में ही है. I don't remember question number, but that is match the column. ठीक है? तो आप कर लेना. Now this question was damn easy, है ना? You people did it? किया आप लोगों ने इस क्वेश्चन को? Just let me know. Was it done? ऋषभ, solved it? तुम लोग इजी क्वेश्चन छोड़ रहे हो. दिस इज वेरी बैड ना. डिफिकल्ट क्वेश्चन में तो लगना ही नहीं है. अच्छा, अदर पेपर वाज देयर? रियली? अच्छा, you people used to get different paper, right? Oh my god. Anyway, if you need the paper, I will be sending you for that match and column wala thing. Okay, that question I will send to you. Okay. So this question is very easy now. Binding energy per nucleon is how much? If you see carefully, what will be the value here? Binding energy per nucleon for C12 is given. Per nucleon means it has how many nucleon? 12. Binding energy per nucleon is how much? 7.68 MeV. So total binding energy of C12 will be how much? 12 into 7.68 MeV. And for C13, binding energy per nucleon is how much? 7.47. What will be binding energy total for C13? It will be 13 into 7.47. Okay? The energy required to remove a neutron from C13. So what if we are removing a neutron from C13? So C13 is element, then we are removing neutron from it. If you're going to remove a neutron from it, what will happen? It will become C12. So the question is simple. If C13 is getting converted to C12, how much energy will get released or how much energy will be required? Then, so what is the binding energy of C13? That is this one. What is the binding energy of C12? That is this one. So whatever energy is required will be difference of these two, right? Done. So that will be the answer, just difference of these two. Okay. Now there was this another question. This one was again very much easy. I said only easy and average questions I have taken. A current carrying wire hits a metal rod. Then there is a current carrying wire and it's hitting a metal rod. The wire provides a constant power P, yani ki whatever rod is getting hit, then is getting power constantly at how much P? It means it is getting hit at the rate of P per unit time. Then the metal rod is enclosed in an insulated container, and this is in insulated container. Means whatever power it is getting, it is not releasing it to the atmosphere. That all energy is getting remained with it only. Done. Now what is happening? It is observed that temperature in the metal rod changes with time. Temperature will change definitely if we are giving it power, if we are giving it heat. What will happen? Its temperature will change, and its temperature as a function of time T is given, and that is how much T naught 1 plus beta T ka power 1 by 4. This is the temperature given as a function of time, right? Beta is a constant with appropriate dimension, while T naught is a constant with dimension of temperature. The heat capacity of the metals. Pucha hai, what will be the heat capacity? Now, how we write the heat capacity? Very simple thing. How we write that? How we write heat capacity? So, if you're going to write heat capacity का formula क्या होता है? How heat capacity is different from a specific heat capacity. Let me know fast. क्या होगा यहाँ पे? क्या equation हमें लिखना चाहिए? Just take some 30 seconds and think about which formula and how you're going to write it. That's also important. Then only knowing the formula is not going to help. ठीक है? चलो क्या लिखोगे? Yes, in terms of power, how you will write it? No. जैसे हीट को क्या लिखते हो? क्यू को क्या लिखते हो? ms delta t, right? We write like that, no? This ms is what? This ms is what? Just divide by t, okay? So this ms is what? Heat capacity. This is heat capacity, no? Done. So इसको चलो मैं c लिख लेती हूँ. So c dt इसको लिखती हूँ, and इसको small heat dq लिख. Done. Now what we are going to do? Yes. So if you are going to divide it with time, why time? क्योंकि मुझे dq by dt is given in the question, so dq by dt. Now c dt by dt. So this is given as how much? This is power, and this is how much? C. C we need to calculate, right? And T is what? Temperature. That is changing variable, and variable value of temperature is how much? This much. So just simply write that. Differentiate this. T naught plus T naught beta T ka power 1 by 4 divided by time you are going to write. Done. It is also given in the term of time only. Here the variable is also time. So we can easily differentiate it. Now P can be written as what? If you see carefully, P can be written as C. T naught का differentiation तो 0 हो जाएगा. So here we will get T naught beta. T का value will be what? Differentiation of T 1 by 4 will become 1 by 4. T 1 by 4 minus 1. So that is 1 by 4 minus 1 how much? Minus 3 by 4. So C ka value is how much? C ka value is 4P by C T naught beta 4. Sorry, C का value निकाल रहे हैं ना 4P by T naught B t ka power 3/4. This is the value of C. But in the option, if you can see carefully, in the term of time, answer is not given. In the term of temperature difference, it is given. So we need to replace this time by T, temperature. How we can do that? We can do very easily, na? That we can do from here only. यहाँ पे ध्यान से देख लो. In this equation, जैसे T minus T naught का वैल्यू कितना है? T naught बीटा, T का पावर 1/4, डन. So T minus T naught by T minus T naught by T naught beta is equal to T 1/4. We have to write the value of T 3/4 so that we can easily do. Cube कर दो, इसको भी क्या कर दोगे? Cube कर दो. So that value you will be putting here and getting the answer, right? So the question is quite easy. Done? Clear? We only need, like here we don't need to worry about mass, because it's asking about heat capacity, not a specific heat capacity, right? So heat capacity is ms. Done? Chalo, done. Now this question, this one actually I wanted to discuss. So यहाँ पे what the question is, this is a very beautiful question, but again not that difficult. Average question, I must say, not easy but average. A particle of charge q is moved from infinity to where? एक second, just give me one. Yes. So what is happening here? A particle of charge q is moved from infinity to center of a hollow conducting spherical cell. So this is a hollow conducting spherical cell. Okay. And what is happening? There is a charge q at infinity. We are moving this towards that. And thickness of this is, it has some thickness, and its thickness is how much? T. And that T is very, very less than its radius. Okay, that is given in the question. And this charge, what is happening? Q is moved from infinity to center of hollow conducting sphere. So we are taking it from infinity to center through a hole. Suppose there is a small hole here, and through this hole we are taking it to the center. Okay. How much work is done by external agent in the process? Question is how much work will get done. Now, initially system हमारा क्या है? चलो, let's take this as the system. ठीक है? So initially these two are infinitely separated. Their energy will be what? Potential energy of the system will be 0. There is no kinetic energy because none has any sort of velocity. Done. So overall energy of system initially is what? 0. Finally, what the system will look like? सबसे पहले इस पे focus कर लो. So finally my system looks like कि यहाँ पे एक hollow conducting sphere है. इसका कुछ certain thickness है. This is the thickness. And there is a small charge q at the center. This is the final configuration, right? Finally, what will happen? So what this system will look like? If this is a charge, done, and this is a conducting cell, it has thickness. This thickness will have some free charges. Done. What will happen to that free charges? That free charges will get attracted. I have very beautifully discussed electrostat in first or second class. So यहाँ पे क्या होगा? Plus charge, negative charge will come to this surface and positive charge will come to this surface. So because of this charge separation or this charge assembly, this q charge will have certain potential energy. Because this charge configuration, there will be certain potential at the center. होगा ना? जैसे मेरे पास एक इस पे पॉजिटिव चार्ज है एंड यहाँ पे एक दूसरा और सेल है, इस पे नेगेटिव चार्ज. सो व्हाट विल बी द पोटेंशियल एट द सेंटर? अगर इसका रेडियस r है, कैपिटल R है, बिकॉज ऑफ पॉजिटिव चार्ज, पोटेंशियल एट द सेंटर विल बी हाउ मच? kq/r. अगेन सेम अमाउंट ऑफ पॉजिटिव चार्ज विल गो आउटवर्ड, वैल्यू ऑफ q it will take, है ना? So kq/r, and what will be the potential due to this negative charge? That potential will be negative minus kq/r plus t. ठीक है? That will be the potential. So there is, what will be the total potential? We will add these two, and if we are going to add these two, what value we are going to get? R plus t minus r, that is t into kq/r, r plus t. This is the potential, net potential value. So potential energy of this charge q will be how much? Potential energy of this charge will be potential into charge that is Q into potential value T into KQ by R plus T. So this is the potential energy of this charge. Is there any other energy that has come or that is here because of this charge configuration? If you look at it carefully, generally what we do now, we easily get to notice this wala thing, but that thing we generally miss. And what is that? If you just ignore this charge Q, don't look at that now. So आप देखोगे कि this system looks like this. Here there is a negative charge and here there is a positive charge. And if you remember capacitor wala discussion, you must be realizing that this is a spherical capacitor. This is what? This is a spherical capacitor. And it will have certain potential difference between these two. Suppose it is V, we can calculate that. And it has certain capacitance. How much capacitance? I have given you the formula. 4 pi epsilon naught AB by B minus A hota hai, where B is the radius of a larger sphere and A is the radius of a smaller sphere. So we know capacitance. We can calculate potential difference between these two. What will be the energy stored in this capacitor? That will become half C into V ka square. So how much energy we are getting? This energy is getting because what we did now, we were taking a positive charge towards a spherical cell. So we were doing work on that charge, and that work is getting stored in the form of potential energy of this capacitor and in the form of potential energy of this charge. So for charge, we have already calculated. For a sphere, for capacitor, we need to calculate. So chalo main potential difference nikal deti hu ek baar. What will be the value? Just calculate potential first at the top surface. What will be the potential of this capacitor plate? So potential because of negative charge will be how much? Here there is a negative charge, right? So what will be the potential because of that? If you see this negative charge, what will be potential because of that? So that will be minus KQ by how much? R. Done. And what will be potential here because of the positive charge? It will be equal to KQ by R. So total potential at the outside sphere will be how much? 0. Okay. What will be potential at the inside surface? So this will be because of negative charge, it will be minus KQ by R. And because of positive charge, it will be how much? Sorry, KQ by R नहीं होगा, ये distance मुझे लिखना पड़ेगा. So this distance is how much? This total is R, this is T. So this will be R minus T, sorry, R minus T. Done. And what will be that potential because of the positive charge? It will be same as that on the surface. So that will become equal to KQ by R. Now you simply add these two. That will give us potential of this negative sphere. Done. Calculate its value. Suppose it is V dash. So the potential difference between capacitor plates will be V dash minus 0. Okay. That will give you the value. Done. Okay. So I just wanted to show you what will happen because of this charge coming at the center. What is happening? Yes, at center some potential will get created. So this charge will have certain potential energy that we will write. And because of this charge, what we are getting such kind of configuration. This is like a capacitor. So this capacitor will store certain kind of energy that will be equal to half CV square. Just calculate potential difference between these two spheres. Okay, that will give you the value. Okay, done. Now what will be its thing? Just let me know its answer. I'm giving you 1.5 minutes again. This is a very easy question. I just want to check if people remember formula or not. Just let me know what value you're getting. Yes. Yes. Correct. So how you solved it? Like what the question is, a star is molded as a uniform spherical distribution of matter, keeping mass of a star constant. How gravitational pressure P at center of a star depends on volume V. Now, what is the gravitational pressure here? You just see here what will happen. If I'm talking about this point, suppose, and I'm asking what will be the gravitational pressure at this point, how you will calculate it? This question were there in your paper yesterday. Or you solved it now? Okay, अच्छा, कल था. Done. So how you will calculate the pressure here? What will be the value? देखो, actually क्या है ना? If I go deeper into the formula, but let me explain in a very layman term, and that is, suppose कर लो कि मेरे पास एक ऐसा plank है, एक ऐसा plank है, एक ऐसा plank. Done. Now, if I'm asking कि pressure acting on B will be contributed by which block? Only C, right? Because C is on the top of B and it will push it down. So pressure is getting exerted on B because of what? Only C. Similarly, acha, done. Okay. So on A, pressure will get exerted by C, B, A, everything. Sorry, C, B, done. So if I'm asking pressure getting exerted at this point, it means whatever mass of Earth is in this region will exert pressure on that. Done. So we will see ki how much gravitational, how much G value will be here. Done. That we will check. Simple. Hai? So that we are going to check. Now force acting will be equal to G into M. Okay, mass. Now pressure will be divided by area. Done. So G का value तो तुम्हें पता है ना? What used to be the formula? Minus GMR by RQ. This is the like for a sphere you must have studied. If there is a solid sphere and at distance r, if we have to calculate the gravitational field value, then that will be equal to how much? Minus GMR by RQ. Done. Now, a star is molded as a uniform spherical distribution, keeping mass of a star constant. How gravitational pressure P at center of a star depends on volume V of the star. At the center of a star, we have to calculate. Done. So now, this is the gravitational field at certain point के लिए निकाल रही हूँ. At this point R. Now, what we need to check with? We need to check कि how much pressure will act at this on this cell. How much pressure will act? How much pressure will act? You just need to multiply it with what? Force I'm going to write now. So force you will get after multiplying mass of this portion into what you will do? Into G dash you will be writing. And the pressure will be equal to what? So if this is, its area will be how much? Its area will be 4 pi r square. तो चलो एक काम करती हूँ, मैं एक छोटे से 3 सेल की वजह से यहाँ पे प्रेशर निकालती हूँ. ठीक है, आई एम फर्दर ईजिंग द क्वेश्चन, नॉट बिकॉज ऑफ होल मास आई एम कैलकुलेटिंग, बस बिकॉज ऑफ दिस थीन मास. ठीक है, थीन मास सेक्शन, what pressure will act on this layer. ठीक है, because of this thin mass section I am going to calculate. तो suppose कर लो its thickness is dr, its radius is r. Done. So G dash m का वैल्यू मैं लिखने जा रही हूँ. So m का वैल्यू how much I will write? 4 pi r square dr. This I will do, right? So how much value you are going to get? G dash का वैल्यू मैंने कितना रखा था? GMR by RQ into how much? This will get cancelled now into dr. So how much value of pressure I have done actually? So how much value of pressure we are getting? Pressure का value है minus Gm by RQ R dr. Now R will vary from where to where. If we have to calculate pressure at this point, just see carefully. At this point, R will vary from where to where. I have told you कि pressure will get exerted because of this portion only, na? I have explained from here. So for calculating pressure on this portion, because of all the mass of a star above, we will take mass from where to where? R to R. Okay, from here to here. सो यहाँ पे बहुत ही वाइजली रखेंगे R2R, ठीक है। अब आप इसको सॉल्व कर लो, -GM/RQ, RDR का वैल्यू क्या हो जाएगा, R²/2, and that will vary from R to R. So -GM/RQ, how much value we will be getting? We will be getting R²/2 minus R²/2, something like that we are going to get. Let's concentrate on the values first. So we have to calculate pressure at center now. So for center, R will become equal to what? 0. So what is the pressure modulus we are getting here? Calculation ध्यान से देख लेना, but logic is correct, ठीक है। R³ into R²/2. So what value we are getting? GM/2R. If I have written everything correctly, ठीक है। So that is this. Now we have to see कि ये pressure volume से कैसे vary कर रहा है। Then now let's see volume क्या होगा, 4/3 pi R³. So V is directly proportional to RQ. R will be directly proportional to V का power 1/3. So R can be written as V का power 1/3. लेकिन यहाँ पे आंसर इज -4/3. सो कहाँ कैलकुलेशन में मिस्टेक हुआ? लेट मी नो, वेयर इज द मिस्टेक? जल्दी से बताओ कहाँ पे गलत गया। लेट मी क्रॉस चेक। हाँ, you also figure it out and let me know. I'm also checking with that. यू गॉट द पॉइंट। यहाँ पे मैंने फॉर्मूला में रो को मिस किया, ठीक है। फॉर्मूला जी डैश का क्या होता है, GM रो होता है ना यहाँ पे। ओह माय गॉड, दैट वाज द एरर हियर। ये क्या होता है, GM रो R/RQ, माइनस डायरेक्शन will tell about you कि gravitational field is, yes, रो was missing, gravitational field is towards the center. तो देखो इसको मिस्टेक होने से कितना बड़ा मिस्टेक हो गया। यहाँ पे रो लिखो आप, यहाँ पे रो लिखो आप। सो यहाँ भी मेरा क्या होगा, रो होगा, यहाँ भी रो होगा। नाउ रो इज व्हाट, मास पर यूनिट वॉल्यूम, है ना। रो इज व्हाट, मास पर यूनिट वॉल्यूम। सो GM/2R इंटू मास जो भी पर यूनिट वॉल्यूम। आर इज वॉल्यूम का पावर कितना, कांस्टेंट ले लेती हूँ अब मैं सारे को, डिवाइडेड बाय R इज प्रोपोर्शनल टू V 1/3. V 1/3 plus 1, V will become 1/3 plus 1 will be equal to 4/3. So pressure is directly proportional to how much, V का पावर -4/3, ठीक है। चलो डन। Now again this question was very much easy. You did it. You just needed to manipulate with the things. You people did it or not? देखो यहाँ पे ना बहुत एक्चुअली क्या होता है ना, इन एग्जाम्स आवर माइंड वर्क्स अभी प्लेस, थोड़ा नर्वस भी होते हैं हम, बट ध्यान से अगर आप यहाँ पे देखो, these are two spheres ना, sorry, these are two disk, one is having sigma 1, one is having charge sigma 2. Now what will happen, this sphere will repel this one, it will apply on it force in this direction. Similarly this sphere will repel this one in this direction, and by Newton's third law these two force must be equal, है ना। If this is जैसे हम लोग जब मैकेनिक्स पढ़ते हैं तो जनरली थिंग्स यूज्ड टू बी इन कांटेक्ट एंड देन फोर्स एक्ट, लेकिन यहाँ पे चार्जेज को कांटेक्ट में होने की जरूरत नहीं है टू अप्लाई फोर्सेस, बट स्टिल न्यूटन थर्ड लॉ विल बी ट्रू। यहाँ पे देखो, वट एवर फोर्स फर्स्ट इज अप्लाइंग ऑन सेकंड, सेम फोर्स सेकंड विल अप्लाई ऑन वन, है ना। yes, D is correct, and if D is correct B will also be correct, है ना। if D is correct B will also be correct. Now how D is correct, So F12 will be equal to F21. Now F12 will be equal to how much? F12 will be equal to how much? Force on 1 because of 2. So because of 2 here, electric field will be how much? Sigma 2 by epsilon naught. Done. Sigma 2 by epsilon naught. And this into what you will be writing? Sigma 1. That we will be writing now. Then this is force. Now this force thing is written in terms of phi. What will be phi 1? जैसे देखो इलेक्ट्रिक फ्लक्स का फॉर्मूला हम लोग क्या लिखते हैं? इलेक्ट्रिक फील्ड इनटू एरिया. इलेक्ट्रिक फील्ड कैन बी रिटन हियर इन द टर्म ऑफ व्हाट? सिग्मा बाय ए. सॉरी, no, sigma by epsilon naught area. Done. And what I'm going to do? Yes. So sigma by epsilon naught into area. And here you see sigma by epsilon naught. So this can be equal to phi by A1. Okay. This can be equal to what? Sigma. What I'm doing? Oh my God. I just wanted to relate those things. F equal to Q. Yes. Force equal to Q into E होगा ना? Yes. So मैंने वो गलत किया शायद. After certain time, my mind stops working. QE होगा ना? Force का value. चलो general formula निकाल लेते हैं. ठीक है? Let's not go into like this. So Q into E will be force acting now. So अगर मैं कोई भी एक sphere की बात करूं, तो इस पे force क्या लगेगा? On this force will act because of electric field getting created due to this. So electric field getting created due to this will be how much? Sigma 2 by epsilon naught, and charge on this sphere will be equal to how much? Sigma 1 into A. Now we need to write it very carefully क्योंकि हमारे क्वेश्चन में ऑप्शन 5 के टर्म में दिया है. So if I am going to write here, what will be the flux through the flux का formula क्या लिखते हो? E into A, area, electric field into area. So sigma by epsilon naught into area. So here sigma 2 by epsilon naught into area. This will become how much? This will become, if we have to go through this, sigma 1 is this.
It should be phi 1.
Now. Yes, sigma 1A, that is phi 1, right? So here phi 1 into, that is coming sigma 2 by epsilon naught. Okay, let's equate it then. Let's check now. Phi 1 into sigma 2 by epsilon naught will be equal to what? But I'm getting opposite. Oh, aren't we getting opposite? Force charge into electric field. Force I'm calculating on this one. So electric field I will be taking because of this. Sigma 2 by epsilon naught, sigma 1 into A, sigma 1 into A. How that one you are taking as phi? Yeah? That won't be phi. No? Phi is what? Sigma A by epsilon naught is phi. Now you just see here carefully, flux through this, flux through first one will be because of second one. No? Flux through first one will be because of second one. So यहाँ पे अगर मैं flux through second one की बात, first one की बात करूँ, तो I will be writing here what? Sigma 2 by epsilon naught into area of first one. Done. So this is area of first one, and this is sigma 2 by epsilon naught. So sigma 2 by epsilon naught into A1 will become phi 1. Did you get me what I did? जैसे यहाँ पे देखो, we just need to be careful. I have written here what? I have written flux can be written as electric field into area. So in general, this is sigma by epsilon naught into A. If we have to calculate flux through first one, so flux through this will be because of electric field getting generated because of second solid disk. Done. So electric field we will be taking because of second one. यानी कि charge we are going to take because of second one, that is sigma 2. So here I have written sigma 2 by epsilon naught. Electric field will be because of second one, and area obviously we will be taking off the sphere or disk through which we are calculating flux. So flux through this will be equal to how much? Sigma 2 by epsilon naught into A1. Done. So here sigma 2 by epsilon naught into A1 will become phi 1 into sigma 1. Similarly, with this we will do, then force will come as phi 2 sigma 2, and this 2 will be equal. So that is why we have equate. Okay. Again, little things matter. So how many questions? Only one is left. चलो मैं इसको discuss करती हूँ एक बार. So what the question is, there is a positive charge particle of mass m and charge q that is projected in a rough horizontal xy plane. Then xy plane में उसको throw किया गया. Now what the case is, electric field is in k direction, minus k direction. Magnetic field is in minus k direction. Particle is entering at this point, x is a. Particle enters the field at a 0, 0. With velocity is in which direction? V naught j. The particle starts moving in curved path on the plane. Done. If coefficient of friction between particle and plane is mu, then ठीक है. तो बहुत ही ठंडे दिमाग से question is not difficult. Again, that is why I have taken. It is very easy. Now you just need to draw the diagram carefully. So particle is entering at which point? A0, 0. तो इस point को आप क्या मान लो? A0, 0. Now its initial velocity direction is where? It is in j direction. तो चलो मैं इसको y axis मानती हूँ. This is minus y axis, this is x, and this is minus x, and z will be perpendicular to this plane, right? So what I'm going to do now, this particle is initially in which direction it has velocity? Y direction, v naught velocity. As soon as it will encounter magnetic field at this in this region, what will happen? A magnetic force will act. Magnetic force formula is Q V cross V. And if you remember here, V is in J direction. B is in which direction? Minus K. And J cross minus K क्या होता है? J cross K I होता है. J cross minus K is minus I. So its center will be somewhere here, minus I direction, somewhere here. Like this circle, it will go round and round and round. Now what is happening? There is also an electric field, and it is acting in negative direction, negative k direction. Now what the question is, time when the particle will come to rest, time when particle will come to rest, that we have to calculate. Why will it come to rest? First thing, because friction is present, done, and friction coefficient is given, that is mu. So what will happen? अब इस question को ना हम लोग एक mechanics का question में convert करते हैं. So this is a charge particle of certain mass, suppose कर लो m mass है, initial velocity v naught था. We already know that if there is no other forces acting but only magnetic force, then that force will act towards the center, and this force will not change the velocity. But here what is happening? Friction is present, and friction opposes the motion. So if particle is moving in this direction, friction will act in this direction, and that will try to change the velocity. That's the simple. And gradually what will happen? Radius of this circle will decrease. R equal to क्या होता है? mv by qv. Radius of this circle will decrease, and at a point it will come to rest. ठीक है? We have to calculate that time. तो सबसे पहले एक काम कर लो, just try to calculate कि what will be its acceleration. ठीक है? Because of that acceleration it will come to rest ना. Just forget about the centripetal acceleration. Which acceleration or which force will try to stop it? Friction. This is friction. What will be the value of friction? Mu n. Now, if you're going to write its free body diagram, mg force will act downward, and also QE force is acting downward. Because electric field is in downward direction, so QE force is acting downward, and the surface will apply on it Newton normal force. Normal force will be equal to QE plus mg. So यहाँ पे friction force will be mu QE plus mg. Okay, this will be the friction force. Now, what will be the acceleration? Acceleration will be equal to QE plus mg by m. This is the acceleration. Because of this acceleration, it will do what? It will stop. Again, you don't need to care about the direction, क्योंकि हमेशा ही जब velocity से opposite होगा हमारा क्या? Friction. So always it will try to reduce its velocity, its acceleration. along tangential direction. ठीक है, done है. Now you have to calculate what time when the particle will come to rest. So when particle will come to rest, how you will calculate that time? अब देखो time को आप कैसे calculate करोगे? So V equal to क्या होता है? U plus AT. Done है, simple है. A is constant, right? So V will become 0. U is how much? V naught. A we have already got T. So V naught by A. V naught by A, if you're going to do, you will get M V naught mu mg plus q. So B will be the answer. है ना? Now distance traveled by particle when it comes to rest. अब distance आप easily निकाल सकते हो. कैसे? You know the acceleration value. Acceleration can be written as what? dv by dt equal to this value. Again, we require the distance now. So dv by dx into dx by dt will be equal to this distance. Again, dx by dt will become what? V. So v dv will be some constant, that is acceleration, into dx. Differentiate on both sides. Velocity will vary from v0 to 0. Okay? We have to calculate after how much distance it will come to rest. So x will vary from 0 to x. You calculate from here, right? So that we will do. Now, rate of turning of velocity vector of the particle. Rate of turning. How we will calculate rate of turning of velocity of particle? Why it is turning? You just remember why anything turns. अगर कोई भी चीज यहाँ है, why it is turning? It is turning and it is going in a circle, right? So why it is turning? Because it has some angular velocity, right? It means it has some torque acting. Sorry, not torque, like it has some angular velocity now. That is why it is turning. What will be the rate of turning? It is asking now. Yes, rate of turning of velocity vector. So what will be the rate of turning of velocity vector? So that velocity, which one we are going to consider? जैसे आप ध्यान से देखो, just हमें rate पूछ रहा है कि constant रहेगा या नहीं रहेगा. Why it is turning? It is turning because some centripetal force is acting. Simple सी चीज है. If centripetal force will not act, it will not turn. Right? It will go like, अगर centripetal force को आप यहाँ पे stop कर दो, it will go away in the tangential direction with certain velocity. Done. So it is turning because tangential force is acting. Sorry, gravity, centripetal force is acting, and centripetal force here is what? Q V cross B. Done. So if you are going to check here, velocity changing with time now. So QB into dV by dt. And this velocity changing with time, but dV by dt is what? Constant. Na? यहाँ पे acceleration है, that is constant. So rate of turning of velocity vector of particle remain constant throughout its motion. Yes, that will remain constant. Okay. So the answer will be what? 4. You just need to remember here in D option P, it will turn because it has certain angular velocity. And if check that if that angular velocity is changing with constant vector or with constant value or with variable value. So that is changing with a constant. So D will be also true. Okay. So I wish a question बचा है. This is not a difficult. You all must have done it. I max, I minimum ही निकालना था. So I just wish you all the very best for your exam. And I suggest कि आप लोग सही से relax भी करो and do also revise सही से in the sense कि whatever you have studied, don't refer to any other books. Whatever question you have done already, just go through those. Yes, keep all formulas in your head. That is always important. ठीक है? TIR वाला question. Which TIR? Total internal reflection, na? That we have already done, na? Rishabh? We did in ray optics so many questions. तो मैं कहाँ include करूँ ये बताओ. Today's last class, I guess. Anyway, I'm there for you if you need help. Let me know.
Yes. From the question paper.
From the question paper. Oh, okay. So TIR वाला question में doubt है तुम्हें?
Yes, ma'am. Question number 10.
एक काम करो ना, you have my number, right? So you can directly send me the question and I will be sending you the thing, or I will be also explaining. ठीक है?
Okay.
No, send me. उसके बाद ऐसा नहीं है कि send नहीं करना है, send करना है, ठीक है? Don't hesitate in that. Let me know. I will be doing that. No worries. ठीक है? So in 2 or 3 days, whatever help you require out of me, just let me know. I will be there to solve each and everything. ठीक है? So all the very best. Stay cool and calm and stay positive. Keep doing lots of questions. At the same time, also take proper taste. So sorry, proper rest and enjoy. Bye bye. Take care. Thank you for your time, everyone. Bye bye.